Welcome to day 19 of the Intuitive Calculus course. Today we're going to learn how to solve trigonometric integrals. These are integrals that involve trigonometric functions. Trigonometric integrals can be a little tricky because you usually have to use trig identities, and there are so many trig identities you can use. But to clarify how to solve these integrals, we're going to classify these integrals into 4 cases. The first case is when you have an integral of an odd power of the function sine of x or the function cosine of x. For example, the integral of sine cubed of x dx. The second case is when you have an even power of one of these functions. For example, the integral of cosine squared of x dx. The third case is when in your integral you have the functions tangent of x and secant of x. For example, the integral of tangent cubed of x dx. And the fourth and last case is when you have just tricky trig integrals, like this one, for example. These are integrals that do not fit into any of these cases, and to solve them you just use your knowledge of trig identities. So any trigonometric integrals falls into any of these cases, and we're going to study each of them. We're going to begin with the first case, in which we have an odd power of cosine of x or sine of x. Let's begin with this example. Here we have sine cubed of x dx. And the first thing we're going to do is to write this integral as sine squared of x times sine of x dx. We can do this because we have an odd power, and we can always do this if we have an odd power. We do this because we want to use the identities that says that sine squared of x equals 1 minus cosine squared of x. So we're going to replace this identity in our integral to get the integral of 1 minus cosine squared of x times sine of x dx. Now we can distribute the product inside the integral to get sine of x minus cosine squared of x times sine of x dx. And the integral of the sum of functions equals the sum of the integrals. So this equals the integral of sine of x minus the integral of this other function, that is cosine squared of x times sine of x dx. So we have this. Here we have the integral of sine of x. And we know that this equals minus cosine of x. Why? Because the derivative of minus cosine of x equals sine of x. So the only thing left to do is to solve this other integral. And we're going to solve it using integration by substitution. We're going to substitute u equals cosine of x. So that means that du dx equals minus sine of x. So we're going to substitute. Here we have cosine squared of x. That becomes u squared. Here we have sine of x, and sine of x will equal minus du dx times dx. We can cancel the dx, and here we have minus outside the integral sign. Here we have another minus sign, so these two cancel, and this integral becomes positive. And we have the integral of u squared du. And this is easy to solve. This equals u cubed over 3 plus c. And the only thing left is to substitute back u by the variable, that is cosine of x. So we have our answer here. So you see that solving trigonometric integrals involves using trig identities, and then some technique that you already know, for example, integration by substitution. So in the next videos we're going to consider to consider the other cases of trig integrals, and we're going to solve more examples. That's all for now. Thank you for watching, and see you next time.